Hi everyone, here are your notes for section 7.5. So today we're going to focus just strictly on the tangent ratio. So here we go. You use trigonometry to solve for unknown sides of a right triangle when you are only given a side length and an angle measure. We talked about today in class when we have a reference angle, we're going to label our right triangle in different ways. The side always opposite of the right angle, we consider that the hypotenuse. Okay, so your hypotenuse is always the longest side, and it's the side opposite of that right angle. If my reference angle is that lower right-hand angle, then the leg opposite of it is considered the opposite leg, and the leg right next to it is the adjacent leg. So notice how the adjacent leg and the hypotenuse create the reference angle. So hypotenuse is always your hypotenuse, so your adjacent leg is going to be the leg that's also next to it. If I move my reference angle to up top here, notice my hypotenuse is unchanged. It still is the side opposite the right angle, but now what happens is that opposite leg is down there at the bottom, and your adjacent leg is there on the left. Okay, so your opposite leg and your adjacent legs are interchanged. Your hypotenuse is always in the same spot. Okay, so our tangent ratio, we need to remember that tangent is going to be your opposite leg length divided by your adjacent leg length. So in this diagram, my tangent of A would be BC. So whatever the length of BC is, whether it's 5 inches, 6 feet, 6.24 centimeters, whatever that length is, that's what's going to go in your numerator. And then your adjacent leg is AC. So whatever the length of that AC is. Okay, so tangent is opposite leg over adjacent leg, and then in terms of this actual diagram, it would be the length of BC over the length of AC. Remember when we have two letters with no symbol up over top, that means we're talking about the length. Okay, so here's our first example. We're going to go ahead and find the tangent of A and the tangent of B. So if we're doing the tangent of A first, that means A is my reference angle. The leg opposite, so tangent has nothing to do with the hypotenuse, so I'm going to ignore my hypotenuse, which in this case is 25. Opposite of the A is 7. So I'm going to write the tangent of A is equal to opposite of that is 7. Adjacent to angle A is 24. So the tangent of A is equal to the ratio of 7 over 24. If I changed my reference angle to B to find the tangent of B, again, the hypotenuse is not in play. Now what's opposite of B is 24, and the adjacent leg is 7. So when you change the reference angle, you're going to get the reciprocal of your other tangent ratio. You will never, ever do the tangent of your right angle. So it's always the non-right angles, which is where you're going to be trying to find your ratios. Okay, so now let's go ahead and use some trig to solve for an unknown side. So instead of having an A, now I have an actual angle here. I have 41 degrees. 12 is considered the opposite side. X would be considered the adjacent side. So I have an opposite and an adjacent, so we're going to use the tangent. So now instead of the tangent of A or the tangent of B, we're going to do the tangent of 41 degrees is equal to opposite, 12, over adjacent, length, which is X. Now that tangent of 41 degrees, what is that? Well, we've got some options. We had our table, remember our table here? So what I could do is I could find where 41 degrees, so there's sine, cosine, tangent, so far right column. I'm going to find my 41 degrees right here, and then tangent is over here. So where is the intersecting? It's at 0.8693. So when I go back to my problem, or you can just on your calculator do the tangent of 41, and you're going to get that. Say, oops, I'm in the wrong mode. I need to be in degrees. Let's redo that. Tangent of 41 degrees gets you the 0.8693 if I rounded it to 4 decimal places. Okay, so let's go back here. Slideshow. So we had the tangent of 41 degrees is equal to 12 over x. So the tangent of 41 degrees we said was 0.86. Oh goodness, I don't remember what the rest of those were. Let me pull up I have a table right here next to me. Where is it? 0.86, was it 93? Yep, it was 93. 93 is equal to 12 over x. So now I need to solve that equation for x, right? We should be able to solve that. So how do I get rid of divide by x? Multiply by x on both sides. Now we have 0.8693x is equal to 12. Divide by 0.8693. 8693, and then using my calculator, 12 divided by 0.8693 is approximately, if I round to one decimal place, 13.8 would be my final answer there. Pretty cool, huh? All right, let's do another one. So here we have our reference angle of 32. Opposite of that 32 is 11. Adjacent to it is x. So I'm going to do a tangent of 32 degrees is equal to 11 over x. So now what I'm going to do is I'm going to go to that table, or I'm going to use my calculator. Where's that table? I'm going to find 32 degrees, which is right here. Go over to my tangent, and I get 0.6249. Or use my calculator and type in tangent 32, and I get 0.624, rounding would get you to the 9. So maybe the table will be easier because you don't have to worry about roundings. It's already rounded there for you. Okay, so what did I just say? 6249. 6249. 624 to 9. Remember 6249. So 0.6249 is equal to 11 over x. Solving for x, multiply by x on both sides, that cancels there. So now I have 0.6249x is equal to 11. Divide by 0.6249, cancels out here. 0.6249. So now I get 11 divided by 0.6249. Whoops. 6249 is about 17.6 if I round to one decimal place. You are always going to get decimals with these answers, guys. You're rarely going to get problems where you get a whole number. Okay, so don't be afraid of those decimals. Just round it to one decimal place. All right. And here we have another one. I think this is the last one in your notes. Find the height of the lamppost to the nearest inch. And I know that this picture is probably really bad on your sheet, so maybe you just want to recreate the triangle. So here's our triangle. Our lamppost is H. Down at the bottom leg is our 40 inches, and our angle here is 70 degrees. So if this is my reference angle, H is the opposite, 40 is the adjacent. So I'm going to do a tangent of 40 degrees is equal to H over 40. So now either my table or to my calculator, tangent of 40 is 0.8391 right there. 0.8391, 0.8391, 0.8391 is equal to H over 40. So there's our equation. To solve for H, get rid of the divide by 40 by multiplying on both sides by 40. So now my calculator, I'm just going to do 40 times 0.8391, and I get H is about 33.6 inches would be my units, would be the distance away from the lamppost. Okay, so tangent, tangent, tangent. I know that these are not on there, but I just want to quickly go through a few more with you guys. Where'd they go? Where did you go? That's not what, oh, there it is. There it is. Okay, so if I want to find the tangent of A, so just watch and soak it in, or pause and see if you can do these practice problems. A is my reference angle. Tangent, remember, the hypotenuse is not in play. It's just opposite over adjacent. So the tangent of A in this problem would be opposite, so 45, over the adjacent, which is 28. The tangent of B would be the reciprocal, right? So if I change my reference angle from A to B, then opposite of that would be 28. Adjacent would be 45. For this one, if I want to do the tangent of A, there's my A. Opposite of A is 9. Adjacent to A is 12. If I change my reference angle to B, now opposite of B is the 12, and the adjacent is 9. Okay, and let's go ahead and do a few more solvings just to make sure you got this. Again, here is my 50 degrees, my reference angle, so opposite of the 50 is 13, adjacent is the x, so I'm going to do a tangent of 50 degrees is equal to 13 over x. Then I'm going to go back to my table and find the tangent of 50. So there's my 50 line. So right here, the 1.1918, 1.1918, 1918, 1.1918, right, is equal to 13x. So now when I solve that out, multiply by x on both sides, then I get 1.1918x is equal to 13. Divide by 1.1918 on both sides. So 13 divided by that gets me an answer of about 10.9 degrees. Or it's not degrees, lengths. All right, let's do one more. Let's do one where x is across here. Let's do this one. Okay, so 41 is my reference angle. Opposite of that is the x. Adjacent is the 16. So I'm going to do a tangent of 41 degrees is equal to x over 16. On my calculator or either on the table, let's find 41. 41, so 0.693. 0.8693, 0.8693 is equal to x over 16. Solving for x, just multiply by 16 on both sides. Now I'm just going to do 16 times that, 0.8693, which gets us 13.9. Okay. All right, so tangents. Make sure that you are able to solve for x using the tangent ratio, and make sure that you are able to just make the ratios given a reference angle. Okay, that concludes your notes.